We should have a piece of paper and a pencil out. We have 3 questions to answer. We're talking about ratios and proportions in real life. Like, how do we use them to solve a real life problem? Right, so answer these 3 questions. We'll talk about them. See what you think. See if you can figure it out. Need somebody to read number 1. All right, Nation.
A recipe calls for 3 cups of flour for 2 loaves of pumpkin bread. How many cups of flour are needed for 3 loaves of pumpkin bread?
Right. So we need 3 cups of flour for 2 loaves of pumpkin bread. How many cups of flour do we need for 3 loaves? Good question. So we can figure this out using a proportion. Because if we're making a recipe for food, you may not bake that much. Maybe you don't bake that much. But if you do bake, things have to be in the right proportion for your food to bake correctly. They have to be accurate. So if we have 3 cups of flour for 2 loaves of pumpkin bread, how many do we need for 3 loaves? We can use a proportion. And think, well, how do I set up my proportion? What goes where? What do I put where? What's my ratio? Rate? All that stuff. There's an easy way to figure it out. I call it hand, foot. Like, we're talking about flour, bread, loaves, yeah. But if you follow this, it'll help you set up the proportion correctly every time. Because you have hands and feet. Right? So if you look at your body, as you're sitting in your desk, you're sitting like this. So you have 2 hands, and down here you have 2 feet. Okay. Your left hand goes with your left foot on this side, and your right hand goes with your right foot on this side. So these 2 things go together, these 2 things go together, these 2 are the same, and down here, these 2 are the same. You want to see how that all goes together. So if I set up my proportion, you have to think about what goes together. So the first thing, it says 3 cups of flour for 2 loaves of pumpkin bread. So if I have 3 cups of flour, if I follow my rule, hand, foot, if I have cups on this side, this has to be the same over here, right? So what will this be on this side? Janelle, it has to be cups. So do we know how many cups? Then if I look, 3 cups. So 3 cups of flour for how many loaves of bread? 2 loaves. 3 cups and 2 loaves, they go together. That's one side of your body. 3 cups and 2 loaves, they're together. Because I need 3 cups and 2 loaves. Which means that this side has to be loaves. So now we have hand, foot. Same things on the top, same things on the bottom. Our left side goes to the left side, right side goes to the right side. So now, we have to solve it. Now there's more than one way to solve it. One of the quickest and easiest is to cross multiply and divide. Yes, please. All right, go ahead. Wrap it up.
5 equals 5, 3 times 3, and then equals 9, and then divide 2, and that equals 4.5.
Well, you're right. But I'm thinking our answer would be 4 and 5 tenths, but the problem is we're making bread, baking, and I'm measuring cups at home. That's what. So what do you think?
4.5.
4.5. Yes, it would be better thinking about real length. 4.5. So 4.5 And let's look at it. Let's look at the second one. So when you read number 2. Julia.
A recipe is 1 serving of how many servings can you make with this
So let's set it up. Here's the portion. So what's going to be your hand? What's going to be your feet? Hand, foot. What goes with what goes where? So Nigel. Alright, so we're making servings of each. Alright, so I have 5 servings. Right. So this side has to be servings. Do we know how many servings? We said ounces on top. So how many ounces per 5 servings? Alright, so 22 ounces goes with my 5 servings. Now we can cross multiply and divide. So what is 5 times 55? Divide that by 22. So we need 12 and a half servings. I have a question. Would it matter if we flip these? Would that make a difference? What I'm asking, would it matter if we change? What if we said we would have made servings on top? If I said 5 servings. Well, here we don't know. And ounces on the bottom. Would our answer be different? Does that make a difference? So raise your hand. Raise your hand if you think, yes, this makes a difference. Raise your hand if I say yes. Right, put it down. Raise your hand if you say no. Same answer. So why do you say no? Why do you say no it'll be the same answer? See,
I say no because even if you do it, if you can have the same equation carry it was 55 times 5 divided by 22. It would be the same exact equation.
so because it's the same equation, it still is. Alright, that's good. Are we still on the left side and right side? Because right here it says 5 servings of 22 ounces. Do we still have that?
Yes.
Yes. So as long as we keep our left side together and our right side together, we'll be fine. We don't want to mix anything up. Alright. Our last one, number 3. Somebody read number 3. Damien.
The car uses 6 gallons of gasoline to travel 150 miles. How many gallons will be used to travel 225 miles?
Alright, good question. Gas mileage is important. One day you have a car. So how should we set this up, Damien? Which your hand, which your feet, what's your proportion?
6. Gavin should be in the hand. And Miles should be in the feet.
So 6 gallons, that's our left side. What's our left foot? What goes at 6 gallons?
150 miles.
Alright. Alright, you traveled 150 miles using 6 gallons of gasoline. So about 220 bucks.
It goes on right foot.
About one,
You will get 9 gallons.
one way to check, to make sure as you're reading each problem carefully, look and see if it makes sense. If I have everything where it belongs, add 3 cups and 2 loaves, add 3 cups and 2 loaves, and you can check when you're sitting at your desk, using your hands and feet. Do these 2 things go together? Do these together in my problem? Do these 2 the same thing? I have cups on top, ounces on top, miles on the bottom. Whatever I have going on, you have to look. Read it over a couple times. You want to be stuck. You sit there, and all of a sudden you got this. That's not same hand. Flip this hand. Flip it. Then I can get about it. Like you don't see me. So, let's go over. What about this one? We're going to stop with this. I'll go down here first before we come back. Let's look at this one first. So if I have somebody read the second problem, come on.
The Lattimore paid $150 for a square feet of flooring, 600 square feet of granite ceiling. They need an additional 220 square feet of material. How much will they have to pay for the additional material?
So if they paid $150, 600 square feet of flooring, they need an additional 240 square feet. How much do they have to pay for that additional? So yeah, 30 seconds. Talk to each other about how you might solve this problem. How would you set up? You can show each other how it looks. Yeah. All right. So I need somebody to kind of start it for you. Need somebody to come up and show it. What you talked about, how you solved it, what you thought about it. Somebody. Alright, you can tell me. You really know it? Right over the market and everything? Alright. Alright, so what did you say? How did you set yours up?
I wasn't sure, but first I tried like the easy, I set up the easy part. So I put 150 over, like, yeah, over 600.
So $150. Which means that if we have money here as our end, our other end has to also be money amount. This is 600 square feet.
And
What do you know on the problem?
it said this is an addition of 200.
So where would
So
that go?
I added 600 plus 20 on the bottom.
So you added it together. So why did you add it?
This is an addition.
So they already have 600 square feet. They need 240 square feet
Oh,
more.
never mind. This is how much they need to pay.
Oh, you put it all together and try to figure out how much. I see.
Yes, I just put it 20.
So let's figure it out. How much does it cost for 240 square feet? Did you get your notes? $60. $60. Yes, sir.
But
Yes, so I think that's what, you know, it's mistaken. You should do, well, how much would it cost for everything all together? Like, they got 600, but they needed 240 square feet more. So all together, that'd be 840 square feet. How much would it cost for everything all together? Now we're getting a question. And yes, all together, we did $210 total of all the materials. Very good. Yes,
it was weird because I put 600 and then
but it's okay, you still put the things in there. Sorry. Okay, our last question, I need somebody to read out the nations.
Mike and Patty travel 756 kilometers per hour. The fastest to know the total distance is 1,292 kilometers. How much longer will he have to be in the park?
They traveled 756 kilometers in 7 hours. The total distance is 1,296 kilometers. How much longer do they have to be in the park? They might have an idea. Maybe you need to read that one a few more times. It's part of our rules. You should read a problem more than once, maybe 3, 4, 5, 7 times. Think about what they're asking you, what's going on in this problem. Is it different from the other ones? What do you think, Chuck?
I think 7 and 756 and 1260.
All right. So you're saying in kilometers, we got our in hand and our hours speed of feet. All right. I like that. Good way to think. So you just, what do you say, David?
I think that 756 kilometers should go at the top, and then 7 hours should go at the bottom, and then 1,296 kilometers should go at the top.
That's what Jai said. No, he said the same thing. Alright. But, okay, so let's do that. So 756 kilometers. So how much time do they have left to drive? All right, David.
12 hours.
So they have 12 more hours of driving. Does that make sense? I don't know. It says they drove 756 kilometers in 7 hours. So, it says, how much longer will they have to be in the car? They have to be in the car 12 more hours. It's like half a day. We figured it out.
I'm leaving 5 more hours because already goes to 7.
How'd you get that? How'd you get your answer?
Oh, because I subtracted the 12 hours. That's 7 from 12 hours.
Okay, so let's take a look. If 756 kilometers of traveling took 7 hours, then 1,296 kilometers takes 12 hours. Okay, so they want 756 kilometers in 7 hours. We just figured out it would take 12 hours to go for the whole trip, right?
Yes.
Because their son Chris said, oh, the whole trip is this long. How much longer will they have to be in the car? So sometimes you have to rethink a little bit more. Oh, we wonder how much longer will they have to be in the car. So they already drove 7 hours. The whole trip takes 12 hours. So now he said we need to subtract 12 hours minus 7 hours they already traveled. 5. So Chris's family will have to be in their car. For 5 more hours. Hopefully they have a DVD or something.
Right.
That's not true. Yes.
I put it the other way.
What'd you do?
I did 756 as this, but I did 1,296 as this, and I put 7 as a hand.
Yes, you can do it that way. We talked about that. We could put hours on top of their hands and kilometers as we need. Either way would be correct. Okay, our last thing. Our assignment right here. If you do not finish this, this will be your homework. You can work with a partner or two. Make sure your proportions are right. Check your hand, feet. Make sure they're good.